Hello, welcome to my channel. Today, Home Assistant Hardwired Part 3 Modbus RTU using serial bus RS485. I will be using this extension. This extension have 13 digital inputs and 12 digital outputs relays. Have also RS485 bus on board. Have some additional features like direct switch functionality, toggle or invert, couple of more as well. You can have it pulse counter on digital input. Also, when you look at the extension, you have also the deep switches, which you can use to set the address. So when you turn on first switch, you're gonna have address number 1. When you turn on second switch, you're gonna have address number 2. When you turn on first and say third, then you're gonna have address number 5. The fourth switch is for bitrate selection and fifth for parity selection. Also, most of our Home Assistant instances haven't got RS485 port, so we will have to use USB. So for this purpose we can use RS485 to USB converter like this one. This one I will be using in this video. You can have different one like this one. It's various of them on the market. So let's go to Node-RED. I already prepped the flow so it's easier. So first thing, I have it connected my extension to my Home Assistant. So first thing what we need to do, configure the server. So we will be using serial expert. We will be using serial port using USB. So this is what you need to put. If you got just one, it will be USB 0. If you got more of the serial converters, you will have corresponding like USB 1 or USB 2. Then serial type, baud rate, data bits, parity, and unit ID. Using best way, using deep switches, you can set them. So this, as in previous video, we will be using 13 relays, reading 13 relays, address start from 0. So let's go and check the Modbus map. Okay, this is the Modbus map for the relays, for the outputs, digital inputs, sorry. You can have it as well enable direct switch, invert direct switch, and toggle. Enable direct switch means if you enable direct switch on DI1, then that means corresponding relay output will be acting as a state of the input. So if you got true on on the digital input number 1, the relay number 1 will be coming on. If it's false, the relay will go off. Invert direct switch polarity means if you got true on the direct switch input, the relay will go off. If you got false on direct input, on digital input, the relay will comes on. Invert polarity basically. The toggle function means each high state on or true on the digital input will toggle the relay. So for example, if you have push button, momentary push button, each time you press the button, the relay will change the state from false to true, from true to false. So let's go to Node-RED again. I already pre-programmed, so we can try relay number 1. is on. Say relay number 2 is on as well, so let me switch it off. Okay, I use forced multiple coils to switch them all off just in case, because I didn't know the second one is on. Okay, so let's try to enable direct switch function. When I was trying to do this first, I was trying to actually enable toggle function first. So I was trying to force one of these registers to enable calls on one of these registers, but it wasn't working. So I contacted the support, and the guy told me, if you want to enable toggle function, then you have to say for DI1, so you have to force this register, call on this register to true, then you have to force this register to invert then, and then you can do the toggle function forcing this register. So, and then when you do that, you have to save the configuration. After saving the configuration, you have to either way or unplug and plug it back again to the power, or force the 1002 register to true. So it will reset, basically, restart the unit. So let's try to do this. Let me try to toggle. So I will have to force this register, then this, and then save and restart. So let's retry. Save and restart. As you can see, it's lost connection because it's restarting. And okay, also when I was doing this, forcing these 3 registers, also I forced the third one, I heard the relay comes on. So let's retry and check which relay. I can see it's relay 8 or 7. So let me, no. Yes. Relay 9, number 9 comes on, which shouldn't happen. So I tried different digital input. This is for number 6, I think. Yeah. So I try for number 5. So let me try now. 1, 2. And another relay comes on. I think this time it will be the 8th. Yes. So in my opinion, this Modbus part is not correct. Basically, I'm showing you this because this is what may happen. If you got a Modbus extension with various functionality, the Modbus part may be not exactly correct. So what we can do now, if you really want to have this toggle function, which is pretty handy, or direct switch function, say for example, if you got light switch connected to digital input number 1, and the light corresponding to that switch connected to relay number 1, then it will be ideal if it's connected as a direct switch functionality, because if something goes wrong with your communication to the extension, the light will be always working anyway. So what you can do, this Modbus extension actually have another functionality, good functionality in my opinion. I mean, you can read or write digital inputs and relay outputs and different functions using one register for multiple inputs and one register for relay outputs. So basically, as you know, one register contains 2 bytes, 8 bits each. So we can write or read maximum of 16 coils, for example, on using one register. This one using only 12 and 13. And okay, how to do this? Basically, the best way to show you how it works, it will be to use one of my PLC controllers. I know it's not a scope of this video, PLC programming, but it will be best picture for it. So I got sample program. Say, this is my easier PLC controller. And basically this is the programming tool. I prep, so if we like to use read the digital input using separate registers, I'm using this block. So address 16 means I think 4th input to read, now is off. If you try to force a coil, you're using this block. Basically this is the address number. It's down because the extension is not connected right now. So I was trying to use this PLC to force those coils to enable direct switch on the input number 6, as you can see 1012. But once I put this address, it shows me illegal function and illegal data address fault. So that means that Modbus map is definitely wrong, because Node-RED cannot do so, and this one cannot do so. Must be something wrong with the Modbus map. So okay, this block, like I says, I can use one register, number 1. Let me go back to the Modbus map. To read and write coils, I can use this register address, number 1, using bits. So this block is basically do this function. Using bits may force the coils from 0 to 15 bits, and then in the same time read those coils. So it's a pretty handy block. Using just this block, I can read or write all the relay outputs on this extension. This block, using digital inputs, all 16 bits. So how we can do this how we can use this functionality on Node-RED? Basically, to turn on, say, relays, to turn on first relay and the second relay, we need to send a value, integer value of 5, because this is what is the conversion from bits to integer. This one actually convert to float, but it's the same value basically. So let's try on Node-RED. So let's go to Node-RED. Okay, I already prepped the flow, so we can write coils using bits, read coils using bits, read inputs using bits, and basically this for the direct invert and toggle functionality as well. Okay, how we gonna write coils using bits? How we can write the number 41, say for example, or 0, or this big number as well? We have to use, instead of for single cores or for multiple cores, we need to use preset single register or preset multiple register. In this case, I'm using only preset single register, means I can write two holding register, so I can write an integer value to it. So okay, why 0? Because if we write 0, that means all the bits will be off. For example, this at this moment all they're off. If we write 65,535, all will be on. So let's retry. Read call bits. Why it's showing this value? Because 8,191. So let's we put 800,091 because we got only 13 outputs. Cannot write the non-existing ones in this case. So let's read input bits. To read the coils or inputs, we will need to use function code number 3, read holding registers. Number 4. Let me go and change it for 4. That means that means digital input number 3 is on. So if we try to write number 41, which is the relay number 1 and the relay number 4, it will be on, and the relay number 6. So I try it. Go to the top. Relay number 1 on relay number 4 on relay number 6 on. Switch them all off. So say now if we want to enable direct switch function. So let's go to Modbus map. There you go. Register number 1022, enable direct switch functionality using bits. So say we want to enable direct switch on number 3. I got a switch connected to number 3, so we will be checking it using the switch. We will be using second bit, so let's go and do this. I'm gonna set them all to do the same input. Okay, so let's enable direct switch first. Okay, I heard the relay click. Okay, if you try to enable this function and make sure it will always work after the power restore or something like this, then you will have to force register number 1003 coil on it to true. So I'm not gonna do that because it's not necessary right now. So let's try. So we got input number 3 is on and the relay number 3 is on. So that means the direct switch functionality is working. Let me switch the switch off, and they both go off. Switch it back on. They both come on. Off is off. Okay. Next thing might be enable invert. So click. So relay is on. The input is off. Let me switch the switch. Switch is on. Input is on. The relay is off. And that's how it works. Invert. Okay, next function, toggle. Let me clear it. The relay is 0, off. The input is on. Let me toggle. The relay is on. Toggle again. Is off. Toggle again. Is on. And that's how it works. Also, this extension have another functionality, and it's called counter of digital input. Basically, each high state or true on the digital input will be counted. It could be handy if you got electric meter with pulse output, so it will be counting every kilowatt hour, say, for example. So you can use these registers to read. I'm not gonna program for this function because I will spend much more time again. Basically, this tutorial is to show what you can have it and how to do it. Basically, I think already you have an idea what to do next if you try to read the counter value. Basically, to reset the counter value, you will have to write to that register, say 0, to reset to 0. You can vary a different value probably. I didn't try this function on this extension. I didn't ever need it. I'm not sure what about this. Basically, this is what comes with the extensions. It's a various functionality. Different extension may have completely different functionality again, so it's no really point to talk about. So I think this is all for today's video. I hope you enjoy it. So see you in next video.